Good evening, students. It's almost a night. Uh, Today's lesson, I'm going to start with the electrochemistry, which is also known as redox equilibria. So this is going to be part 1, and tomorrow it's going to be part 2. So let us begin. So basically, when we start electrochemistry, the question comes: what is electrochemical reaction? Then what is electrochemistry? So these are the basic questions that arises when we start this chapter. So electrochemical reaction, it is a process which causes the electrons to flow through the wire. Basically, we are using the term electrochemical reaction, so it is very clear that they are the electrons which are flowing through the wire. So what is electrochemistry? Now it is the branch of chemistry which deals with the study of the conversion of chemical energy into electrical energy, or vice versa, electrical energy into chemical energy. So basically you have to remember here, conversion of chemical energy into electrical energy. So like sodium chloride can be a chemical. Okay, so when we put them into the water, it will dissolve into ions. So the ions are the one which is helping the energy to flow through them, like current to flow through them. They are the medium or the mode of transmission of the energy. Let us differentiate between the following with the examples: between conductors and insulators, metallic conductors and electrolytic conductors, electrolytes and non-electrolytes, and strong and weak electrolytes. So first, conductors. So these conductors and insulators you have been learning in your lower class as well. So allows the passage of current through them, and insulators just opposite, does not allow the passage of current through them. Examples: all metallic compounds, metallic rods, iron rods, they conduct the electricity, so they are supposed to be conductors. Even the water can conduct the electricity. The insulators examples are rubber, plastic, dry wood, etc. Rubber, plastic, dry wood, etc. they do not conduct the electric current, so they fall under the examples of insulators. Electrolytic conductor conducts electricity in aqueous solution or also in the molten state, and they conduct electricity due to flow of ions. The conductance is directly proportional to temperature. When temperature increases, conductance also increases. When temperature decreases, conductance also decreases. Some examples are aqueous copper sulfate, molten lead bromide. Metallic conductors, just opposite, conducts electricity in solid state only, does not conduct electricity in the molten state or in the aqueous solution state. So they are supposed to be metallic conductor. Because of the flow of electrons, they conduct the electricity. Now conductance is inversely proportional to temperature. So when the temperature increases, conductance is less. And when the temperature decreases, conductance is more. For example, metallic bar. Electrolytes, substances that produce ions when dissolved in solvent, are known as electrolytes. And when it does not produce ion on dissolving in the water, or any solvent, it is known as non-electrolytes. Polar compounds, most of the polar compounds are electrolytes because they easily get dissolved into ions. And non-electrolytes, most of the non-polar compounds are non-electrolytes. The electrolytes can conduct electricity, but the non-electrolytes cannot conduct electricity. Example: sodium chloride, magnesium chloride, and other ionic compounds. Non-electrolytes are example: sucrose, glucose, urea, etc. Strong electrolytes and weak electrolytes. Strong electrolytes, compounds that completely dissociate into its ions when dissolved in water, and compounds that do not completely dissociate into its ions when dissolved in water is the weak electrolytes. Though weak electrolytes dissociate, but they produce less number of ions. So therefore, in the second point, you can see under the strong electrolytes produces large number of free moving aqueous ions. Examples are all strong acids and bases. Strong bases are the example of strong electrolytes. And weak electrolytes, second point, produces a small number of free moving aqueous ions. Example of weak acids and weak base. Now the main topic is galvanic cell, or also known as electrochemical cell or Daniell cell. So what is galvanic cell? Galvanic cell is a device in which the chemical energy is converted into electrical energy. So basically we have to remember this chemical conversion of chemical energy into electrical energy. It generates electricity on accounts of a redox reaction occurring in it. Redox reaction is a reaction in which the oxidation and reduction reaction takes place simultaneously. So basically in a galvanic cell, redox reaction also takes place as well as the oxidation reaction takes place. So both together it is known as a redox reaction that takes place in the galvanic cell. Some common example of galvanic cells are like dry cells, fuel cells, mercury cells, lead acid battery. These different types of cell we are going to learn in the third part of this electrochemistry. Construction of galvanic cell. Galvanic cell is basically constructed by combining oxidation half cell with the reduction half cell. I have mentioned that it undergoes redox reaction, so therefore it is necessary to mention about the oxidation half cell where the oxidation reaction takes place, reduction half cell where the reduction reaction takes place. Solution that we are going to use in the individual electrodes known as electrolytes, which will be involved in two electrodes. Solution involved in two electrodes, zinc and copper. They are connected or communicate with each other through a salt bridge, which is a U-tube shaped test tube containing the inert electrolytes. So you have to remember the inert electrolytes that are used in the U-tube shape, like potassium chloride, potassium nitrate, sodium thiosulfate, ammonium nitrates are some of the examples of inert electrolytes that is used mixed with agar-agar, and it is put in the U-tube shape test tube, which will then function as the salt bridge. Metallic rods are also connected with an ammeter or multimeter or sometimes voltmeter use. Basically in our lab we have the multimeter, which gives the reading of where we get the reading of resistance, also current also, by means of an insulated wire. Ammeter or multimeter is used to measure the flow of current or the resistance. Now this is the diagram that gives us a picture about the galvanic cell. It talks about the construction part. So you can see that this two container contains this one container is known as the oxidation half cell, the another one is known as the reduction half cell. So both together redox reaction takes place. Then this is the metallic electrode of zinc, and this is the metallic electrode of copper, and they are externally connected by the wire which is connected to voltmeter or ammeter or the multimeter. Then you have this salt bridge, which is made up of, which is a U-shaped test tube which contains the inert electrolytes mixed with the agar-agar. So now this zinc electrode will be dipped in the zinc sulfate solution. It has to be dipped in its own salt. And copper metallic electrode will be dipped in the copper sulfate solution. Now you can see that this indicates the flow of electrons, and in the opposite direction indicates the flow of current. So electron flow and the current flow, they have opposite direction. Now you can easily remember the construction of the galvanic cell through this mnemonics lone and RRCP. So basically when I teach, I use this term lone and RRCP. From the lone you can use L stands for left. Always your oxidation half cell will be on the left hand side. So therefore left. O means oxidation, oxidation reduction, oxidation half cell. Then A stands for anode. So this is anode. Anode, and N stands for negative. So because anode is a negatively charged plate. Then just opposite, L opposite is R. Left is right, oxidation is reduction, anode is cathode, negative is positive. So if you remember loan, you can easily write for the reduction half cell because it is just opposite. R is right hand side, reduction half cell. R stands for reduction half cell. C stands for cathode, and P stands for positive. So unlike the electrolytic process that you have learned in class 10, in the electrolysis your anode is positive and cathode is negative. But in galvanic cell it is a little bit different, where anode is negative and cathode is positive. That is what you have to remember. You should not be mixing this concept with the electrolytic cell. Salt bridge, which is also denoted by the two slashes that I have written here. So it symbolizes the salt bridge. So already explained, it is an inverted U-shaped glass test tube filled with inert electrolytes like potassium chloride, potassium nitrate, ammonium nitrate, sodium thiosulfate, etc., which is embedded in the semi-solid substance like agar-agar. So when you prepare this one, you have to mix with agar-agar and the salt together, and it can be fitted in the U-shaped glass tube. The function, so this function of the salt bridge is very important from the exam point of view as well. So basically in the exam you will be asked to write at least two functions of the salt bridge. So you can be smart here. You can choose the one that are very short ones. You can easily remember it. So first one is, it maintains the electrical neutrality of two half cells by diffusion of ions. So it is very important that the electrical neutrality to be maintained between the two half cells, oxidation half cells and reduction half cells, and it happens by diffusion of ions that takes place through the U-shaped glass tube. Cation move towards reduction half cell. Cations move towards the reduction half cell where there is excess of negative charge, and anions move towards the oxidation half cell where there is excess of positive charge. Hence it prevents the accumulation of excess charges on both the anode and cathode. So now what happens here, if I have used the potassium chloride here, potassium will move towards the reduction half cell, chloride, that is the negatively charged ions, will move towards the oxidation half cell. So chloride on coming here will not allow the accumulation of the positive charge more here, and when potassium comes to the reduction half cell, it will not allow the accumulation of negative charge here. So thereby it maintains the electrical neutrality between the two half cells. Now number two, it prevents the mixing of electrolytes present in two half cells. So this is physically it will not allow the electrolytes to get mixed, and it completes the circuit. If you take out the salt bridge, then there will be no reading in the ammeter or in the voltmeter or in the multimeter. So therefore it makes the circuit complete. It also prevents liquid-liquid junction potential. So these are the functions of salt bridge that is very important from the exam point of view. The flow of current and the flow of electrons that I have already explained, it flows in the opposite direction. This one you can see it is a flow of current, and this one you can see it's a flow of electrons. Now this already explained about the anode is a negative electrode, cathode is a positive electrode, oxidation electrode is an oxidation electrode, cathode is a reduction electrode, oxidation half cell takes place here, and the reduction half cells takes place here. So in reference to these diagrams of the galvanic cell, so oxidation reaction should take place in the zinc sulfate, and reduction reaction should take place in the copper sulfate. So let us look at the reaction that is taking place. So zinc will change, it will undergo oxidation, because oxidation especially means losing of electrons, Zn2 plus 2 electron. So zinc basically loses 2 electron to form the zinc cation. And reduction reaction means basically it is gaining the electrons to form anion. So copper 2 plus will gain the 2 electrons that is lost by the zinc to form the copper, neutral copper atom. And both together, if we add the oxidation half cell reaction and the reduction half cell reaction, then we will get the cell reaction, total cell reaction. So oxidation plus reduction is redox reaction. So you will get here this 2 electron and 2 electron will get cancelled. So zinc solid plus copper 2 plus will give you the zinc 2 plus. This type of cell reactions and oxidation half cells and reduction half cell is very important from the exam point of view. The oxidation of metal takes place at anode, and electrons generated move towards the cathode through the external circuit. When electrons reach the cathode, they reduce the metal ions into metal atoms. So this flow of electrons and current is explained by this paragraph. Half cell and galvanic cell representation. This representation, cell notation representation, is also important. Oxidation half cell, there will be formation of zinc 2 plus ion. Reduction half cells, there will be changing of copper 2 plus ion copper. So zinc slash Zn2 plus, or it can be written as zinc sulfate, or slash, you can maintain this slash either in the vertical or in slightly vertical. Then copper can be written as upright vertical or slightly slanting vertical, but you have to mention like this. In the case of oxidation half cell, Zn here, Zn2 plus here, reduction, copper 2 plus here, copper here. Now when we are representing the galvanic cell in the full cell notation form, then you have to write in this manner. The salt bridge is represented by the 2 slash. So this all is important. So this is all lone and RRCP only. So how it is done, the cell reaction, the redox reaction taking place, oxidation reaction and the reduction reaction to give you the cell reaction. So basically in the exam also you will be asked to write this oxidation reaction and reduction reaction plus the cell reaction, and from the cell reaction you will be asked to derive the cell notation representation form. The redox reaction responsible for the generation of electron current in a galvanic cell is called cell reaction. So zinc undergoing oxidation, copper undergoing reduction, so 2 electrons are cancelled. So now when we add up this one, zinc will come here, plus you have the copper 2 plus in the left hand side, and after the arrow you have the Zn2 plus and the copper. So this will give you the cell reaction. Now if you are asked to write the cell notation form, then you will have to write this one. So there are some activity questions given to you. From looking at this activity questions, please write the answer for the given questions. Thank you. Good night.